Unit 2, Force and Motion. These are some of the pictures which depict force and motion. This is windmill, which will be in a rotatory motion, and this child is swinging a tree, again oscillatory motion, and the leaves are falling down, non-contact forces, and rotational path of a train which shows the motion of rotation. And this is a giant wheel which is also rotatory motion, and this clock's pendulum will oscillate. This is oscillatory motion. Introduction. We had studied in our earlier classes that push or pull results in some motion of the object. When we open the door, kick a football, lift our school bag, all involve motion, and there is some push or pull. Motion and rest. What is rest? What is motion? Suppose there is a book on your table, right in the middle. Is the book moving? You will say it is not moving. It is at rest. If you push the book to one side of the table to clear space for keeping your notebook, then you will say the book is moving. When the book was at the same place with respect to the table, you say the book was at rest. But when it was pushed from one place on the table to another place, you say it was moving. Activity 1. Can you identify whether it is push or pull that results in motion in the following cases? See the first picture. A girl is pulling the water from well. A vendor is pushing his cycle. A boy is pushing the tire. A boy is pushing the girl in the swing. A man is riding a bullock cart where the bulls pull the cart. A man pushes the nail with the help of hammer inside a place. What is called motion and rest? When there is a change of position of an object with respect to time, then it is called motion. If it remains stationary, it is called rest. Is Mohan in motion? Observe the following pictures and say whether motion or at rest. This is a small story by which we can understand the motion. In the first picture, Anita and Babu are standing under a tree at the bus stand, waiting for a bus to Madurai. Two more of their friends, Rekha and Mohan, get into a bus to go to Tanjavur. The bus starts. Hey Babu, would you say that Mohan is in motion? Yes, of course. How can you say that? I can see he is just sitting in the bus. Yes, but the bus is moving, isn't it? So what? You never believe me. Ask Rekha. Rekha, do you think Mohan is moving? No, Mohan is not. He is just sitting in one place. Anita tells this to Babu. He snatches the phone from her and says irritably to Rekha, can't you see that the bus has moved away from the tree? Mohan is in the bus, hence Mohan moving along with the bus. But I am also in the bus. To me, it does not look as if Mohan is moving. He isn't moving towards me or away from me. Hi, am I moving or at rest? Discuss who is correct. Is Mohan really in motion? We can readily observe that both Rekha and Babu are correct. From the point of view of Babu, Mohan along with the bus is in motion. But for Rekha, who is sitting beside him, he is at one place, therefore stationary. So, according to Babu, Mohan is in motion. Mohan is at rest from Rekha's observation. Can you think any other examples? Hi, please answer Honeybee by observing the situation in this picture. Event 1. The man in the boat is moving with respect to the bank of river. He is at rest with respect to the boat. Yes or no? He is at rest with respect to the boat. Choose the correct answer. Fill it with rest or motion. In the event 2, the girl on the swing is dash with respect to the seat of the swing. See, the girl is sitting in the seat of the swing. According to the swing, the girl is not moving. With respect to the seat of the swing, the girl is at rest. Next one is she is dash with respect to the garden. With respect to the garden, the girl is at motion. Even 3. Nisha is going to her grandmother's house by bicycle. The girl on the bicycle is dash. So the answer is the girl on the bicycle is at motion with respect to the road because she is not standing in the road, she is moving in the road, and according to the next point, she is at rest with respect to the bicycle. In the bicycle, she is sitting and she is not going away from the bicycle. Take the case of a book on a table at rest. It is really without any motion. We know that Earth is rotating on its axis, therefore, the table along with the book must be rotating, is it not? Imagine yourself as a book and ask this question to yourself that am I in rest or in motion? We are also moving along with the earth. Therefore, from the point of view of ground on which we stand, the book is at rest. Similarly, while traveling in a speeding bus, we feel that the poles and trees seem to move backwards and the things inside the bus are stationary. An object may appear to be stationary for one observer and appear to be moving for another. An object is at rest in relation to a certain set of objects and moving in relation to another set of objects. This implies that rest and motion are relative. Activity 2. Moon or cloud. Observe the moon on a windy night with a fair bit of cloud cover the sky. As a cloud passes in front of the moon, you sometimes think it is the moon which is moving behind the cloud. What would you think if you were to observe a tree at the same time? So actually the moon is not moving because the clouds are moving very fast. It seems to be the moon is moving. When you have been turning around and seeing the tree, it is not moving. So this is the answer. Aryabhatta, an ancient Indian astronomer, said that like the banks of the river appear to move back to a person in a boat floating gently in the river, the night sky studded with stars appears to move from east to west, while earth rotates from west to east. Learn more by asking others and reading up on your own. How things move. When we kick a ball, it moves. When we push the book on the table, it moves. When a bullock pulls a cart, it moves. Motion occurs when the object is pulled or pushed by an agency. Why don't we try an inanimate agency? This is a picture where a pot was pulled out from the well. Because it's moving, it is very difficult for them to move. So what is called inanimate? Inanimate means the thing which is not moving. In daily life, we pulled out water from the well with bucket, or the animal pulls a bullock cart. It is a person or animal that is an animate agency. See in this picture, a man is pulling the water from the well by the pot. So the man is the animate agency who is pulling the pot. Sometimes we see a tall grass in a meadow dancing in the wind. A piece of wood is moving down a stream. What pushes or pulls them? We know that blowing wind and flowing water is the cause. Sometimes the push or pull can be due to the inanimate agency. Forces are push or pull by an animate or inanimate agency. In all the above cases, the force is executed by touching the body. So, this type of force is called contact force. Contact and non-contact forces. See this picture. Yeah, coconut is falling from the coconut tree. Hey, who is pulling me? If the coconut is going to ask a question, this will be the question. Who is pulling that coconut? Mysteriously, ripened coconut falls to the ground. What pulls it to the ground? We would have heard the force of gravity of the earth. Gravity pulls the ripened coconut from the tree to the ground, bringing a magnet near the small iron nail. Suddenly, the nail jumps into the air and sticks with the magnet. Observe that the magnet and the nail did not touch each other. Still, there was a pulling force that made the nail to jump towards the magnet. In these two examples, the force is applied without touching the object. Such forces are known as non-contact forces. Forces can be classified into two major types, contact force and non-contact forces. Wind is making a flag flutter. A cart pulled by a bullock cart are contact forces. Magnetism, gravity are some examples of non-contact forces. Force can be done by means of two factors which are called as agencies. For a force to be done, there are two types of agencies. First one is animate factors, second one is inanimate factors. Types on the basis of contact, there is two types. One is contact forces, another one is non-contact forces. What happens when you apply a force on an object? Say you push a book on the table. The book moves. Application of force in an object results in motion from a state of rest. What happens when a batsman hit a ball? The ball is already in motion, but with the strike, the speed of the ball increases. Moreover, the direction of the ball changes. Application of force on object results in a change in its speed and change in its direction. Crush a balloon. Apply force on rotate off. Pull a rubber band. In these cases, the shape of the object change on application of force. Application of force in object results in expansion or contraction. Look at this picture. The person is applying force to stop the cart from moving. When the force is applied against the direction of the motion, the speed can be reduced or even the motion stopped completely. Discuss what happens when you apply brake in a speeding bicycle. In a nutshell, the applied force is an interaction of one object on another that causes the second object to move from rest or speed up, slow down, stop the motion, change the direction, compress or expand. Forces can change the states of body from rest to motion or motion to rest. Either change the speed or direction or both of the body. Change the shape of the body. Types of motion. Play with pencil. Please do what Shanti did. Shanti took a pencil and sharpened it with a sharpener. Then she drew a circle using the pencil and a compass. Later, she took her ruler or scale and drew a straight line in another paper. Then she kept the pencil between her finger and moved it back and forth. Now look at the motion of the pencil in all these four cases. How was it? In the first case, the pencil rotated in its axis. In the second case, it went in a circle. In the third case, the pencil traveled in a straight line. In the fourth case, the pencil tip moved back and forth, that is, it oscillated like a swing. That is, its motion was rotational and then circular, straight line and linear and later oscillatory. Curvilinear paths. Throw a paper aeroplane or paper dot. Watch its flight path when you throw it at an angle. The path curves, that is, the paper flight is moving ahead but direction is changing while moving. Such paths are called curvilinear. Periodic and non-periodic motions. A fly buzzing around the room is a combination of all these and flight path is zigzag. You can classify the motion according to the path taken by the object. Linear, moving in a straight line like a person walking on a straight path, free fall. Curvilinear, moving ahead but changing direction like a throwing ball. Circular, moving in a circle, swirling stone tied to the rope. Rotatory, the movement of a body about its own axis like a rotating top. Oscillatory, coming back to the same position after a fixed time interval like a pendulum. Zigzag, irregular, like the motion of a bee or people walking in a crowded street. Oscillations at greater speed. Ask your friend to hold the two ends of a stretched rubber band. Strike it in the middle. Do you see it oscillates very fast? When the oscillation is very swift, it is called as vibration. Fast oscillations are referred to as vibrations. Activity 5. Hi friends, tell me what type of motion I am watching the path of my motion. The first one is linear motion. The second one, the answer is curvilinear. The third one is rotatory. The fourth one is zigzag. And the fifth one is oscillatory. So now you can able to make your own answers in this table. So classify the following according to the path it takes: linear, curvilinear, circular, rotatory, oscillatory, zigzag or irregular. You want to identify the paths which has been done by these objects. The first one I will be telling you, a sprinter running in a 100-meter race. The answer will be linear. By the same way, you need to identify these activities and make note of it so that you can able to understand the lesson. Also, add any 5 motions you observe to this list in extra. Speed versus slow. Take the case of the hour hand of a clock. In one day, it makes 2 rounds. Look at the bouncing ball. It bounces a certain number of times for a given time interval or period. Look at the water waves in the given period, that is fixed time interval. A fixed number of waves hit the shore. Motion repeated in equal intervals of time is called as periodic motion. Let us take the example of sabbing swing in wind. This motion is not in uniform interval. Such motions are called non-periodic motion. Can you notice an interesting fact? Do you notice that all oscillatory motions are periodic, but not all periodic are oscillatory? Revolution of the moon around the earth is periodic but not oscillatory. However, the children playing in the swing is both periodic and oscillatory. Look at the tall tree. When the wind is gentle, its branches are dancing slowly. But if the gentle wind becomes strong, the branches shake violently, and if the speed increases further, the branches may even break and fall. This motion can be slow or fast. Can we say a motion is slow or fast without comparing anything? Compared to walking, cycling is fast, but a bus is faster than a cycle. So, slow or fast is relative concept which depends upon the motions we are comparing. Then, how do we say a body moves in a particular speed? From this example, we can learn about average speed. So first, observe the picture. This car. The driver says, I have traveled 160 km in 2 hours. This bus driver tells, I have traveled 200 km in 4 hours. This truck driver tells, I have traveled 300 km in 5 hours. Can you say who traveled with highest speed? The taxi driver, or the bus driver, or the truck driver? How do we say? Let us calculate how long they traveled in 1 hour. The formula is speed is equal to distance traveled by time taken. Distance traveled by a car in 1 hour is equal to 80 kilometers per hour. How they identified that? See, 160 kilometers in 2 hours. The distance traveled is 160 kilometers and the time taken is 2 hours. So they divided 160 kilometers by 2. So answer will be 80 kilometers. The same way, the distance traveled by the bus in 1 hour is equal to 50 kilometers. See that buses travel 200 kilometers in 4 hours. So 200 divided by 4 gives 50 kilometers. The same way, the truck travels 300 kilometers in 5 hours. So 300 divided by 5 gives this answer. So have you found out? Say now, which is fastest? Yes, the fastest is the car and the slowest is the bus. Have you noticed that saying who is fast and slow is easy when we calculate the distance they traveled in 1 hour? What is average speed? The distance traveled by an object in unit time is called the average speed of the object. If an object traveled a distance d in time t, then its average speed s is equal to distance traveled divided by time taken, that is d by t. In other words, you divide the distance traveled by time taken to get the speed. Suppose a car travels 300 km in 1 hour. Then we say the speed of the car is 300 km per hour. We read it as 300 km per hour. kmph is also read as kilometers per hour. kmph is read as kilometers per hour. If an object traveled 10 meter in 2 seconds, Then average speed S is equal to distance traveled D divided by time taken T, that is equal to 10 meter divided by 2 second. The answer is 5 meter per second. Bus takes 3 hours to cover this distance of 180 kilometers. Then its average speed is distance traveled by time taken, the formula 180 kilometers divided by 3 hours. So the answer will be 60 kilometer per hour. Please note that meter per second or kilometer per hour comes next to our answer for average speed. What is it? Observe the formula of the average speed. If we denote the distance in meter and time by seconds, then the unit of average speed is meter per second. Meter by second.